In number 1, we are asked to differentiate several functions. The first one, 1a, is x to the fourth times cosine x. So the derivative will be found using the product rule. We have a function of x times another function of x. What you can do is, when you're looking at a function, count the x's. Every time you see an x, you've got another function. Now, in this case, the functions are multiplied together, so that's why we want to use the product rule. So we'll have the first factor times the derivative of the second factor. We'll have x to the fourth times negative sine x, plus the derivative of the first factor, 4x cubed, times the second factor, which is cosine x. And if you like, you can take out a common factor of x cubed. I think I'll leave it just like that for right now, though. Part B has y equals 3x minus 4 over 2x plus 1. I hope it's easy to recognize the quotient rule possibilities here. You do have a function expressed as a fraction, and so in that case the quotient rule seems to be a natural. So let's use the quotient rule. We'll have the denominator, 2x plus 1, times the derivative of the numerator, that's going to be 3, minus the numerator, 3x minus 4, times the derivative of the denominator, which is 2. And all of that is going to be over the denominator squared, the square of 2x plus 1. Now I am going to simplify this. Here we'd have 6x plus 3 minus 6x plus 8, I believe. And so that should be 11 over the square of the quantity, 2x plus 1. In part C, we have the secant of 5x squared plus 3x plus 2. Now, if this were just the secant of x, it would be a very short problem. There would be not much to do. However, we've got the secant of something more complicated than x. We've got a function inside the secant. That means we have a composition of functions, and we need to use the chain rule. Alright, so how's that going to work? Well, first we need to differentiate the outer function. Well, the derivative of the secant function is the secant times the tangent. Well, secant of what times tangent of what? Well, you don't do anything to the inside function at first. You just leave the inside function inside. And then you multiply by the derivative of the inside function, which would be 10x plus 3. And it might be less ambiguous to write the 10x plus 3 in parentheses in front of this expression. I don't really have room to do that, so I will just leave it as it is and go on to part D, where you've got the cotangent squared of x. Now you need to remember how to interpret this exponent here. That means we're squaring the cotangent of x. This is another case where we have an inside function and an outside function. The inside function is cotangent x, and the outside function is this squaring function. So let's differentiate the squaring function first. We'll bring the 2 down. We'll leave the inside function alone for now. So we have 2 times the cotangent of x raised to the first power, but then we need to multiply that by the derivative of the inside function, the derivative of the cotangent function. Well, the derivative of cotangent x is negative cosecant x. And so we can rewrite that as negative 2 times cotangent x. Actually, it's negative cosecant squared. So we have negative cotangent x cosecant squared x. In part E, we have x squared times the sine of x squared plus 1. You've got a function of x here and a function of x here. You have 2 functions multiplied together. So we're going to want to use the product rule. I'm going to label these as a and b. So the derivative is going to be a times b prime plus b times a prime. Now this b also has an inside function and an outside function. So when we differentiate b, we're going to need to use the chain rule. Alright, let's get started. So here we need a, which is x squared, times b prime, the derivative of the sine of x squared plus 1. Well, the derivative of the outer function is cosine x squared plus 1, times the derivative of the inner function, b sine x squared plus 1 times a prime, that's 2x. There's lots of simplifying that could be done. I see a common factor of 2x, and that'll leave us with x squared cosine x squared plus 1 plus sine of x squared plus 1. Then in part f, we have f of x equals x sine x tangent x. We have three functions multiplied together. So f prime of x will be a b c prime plus a b prime c plus a prime b c. So in this case we'll have x times sine x times secant squared x plus x times cosine x times tangent x plus 1 times sine x tangent x. And I know there's a lot of simplifying that can be done there. Well, maybe not a lot, but some. For instance, I know that the tangent of x is sine x over cosine x, and so the cosine x's would cancel, and you'd be left with just x sine x there for the middle term. And then we could take out a common factor of sine x from all three terms. I think I'll leave that for you to do, though.